All right. There are some additional properties that we can use based on what's inside. Remember last week when we talked about parallelograms, we also learned about the diagonals and what their properties were. In these parallelograms I'm about to show you, we can also prove what kind of parallelogram it is based on the diagonals, based on how it is. Now, let's take a look at this first picture. We see, of course, that this is automatically a parallelogram because we have two pairs of opposite sides that are parallel. All right. Now, what I'm going to do is I'm going to draw the diagonal going from there and going from there. Let me try that again. There we go. All right. Now, let's say that these diagonals meet at a right angle. Okay. If two lines meet at a right angle, they are called what? That's right. They're called perpendicular. All right. If these diagonals meet perpendicularly, they meet at a 90-degree angle, then we can assume, or we can prove that ABCD, the shape ABCD, is a rhombus. So ABCD is a rhombus if and only if AC, line segment, is perpendicular to line segment BD. Okay? And then what that means is it works both ways. If AC is perpendicular to BD, then that just means that ABCD is a rhombus. So it works both ways. Okay? So it's automatically a rhombus. Okay? All right, let's go to the second picture. I'm again draw the diagonals. Okay? I'm going to draw the diagonals. Now this time I'm not going to mark that it's a 90-degree angle or anything like that, but we're just going to mark it like this. All right? However, I'm going to do this. If this is a rhombus, we'll say this is a rhombus, ABCD. ABCD is a rhombus if and only if the following happens. Okay, this is what happens. Like if I have this angle and this angle marked right there, those are obviously congruent, just like this angle and this angle. Those are congruent. All right? And these two angles, although I drew are congruent, and these are congruent as well. All right? Although I drew the lines off a little bit, just assume that that's what's happening here. Okay? So, ABCD is a rhombus if and only if, and there's just a few angles we're going to draw, or say, BCD, which is this whole angle right here, if the measure of angle BCD is congruent to DAB, or BAD. And ADC, the measure of angle ADC, is equal to, I should not say congruent by the way, because I'm talking about measurements. So equal to the measure of angle, let's see, I did ADC, so it would be ABC. Okay? So it's only a rhombus if this angle, if this whole angle and this whole angle are equal, and this whole angle and this whole angle are equal. That's the only way it's a rhombus. Okay? Okay? Let's go to the third picture. Now here, this appears to be a rectangle. So once again, I'm going to draw the diagonals going from A to C and B to D. Okay? Now, here's what's happening here. We already know that they're parallel. opposite sides. We know they're parallel on opposite sides. And we can also do this. Okay? All right? If I can do that, then I can say that the points, that this shape right here is indeed a rectangle. All right? So we're going to say that ABCD is a rectangle if, and only if, the diagonals are congruent. So if the diagonals are not congruent, then you can't say it's a rectangle. Okay? So, as I said earlier, a square is a rhombus and a rectangle put together. So basically, all three of these properties that we just talked about right here will also have to work for a square. All right? And it makes sense, right? Because in this picture, this is a rhombus. Well, a rhombus has 4 congruent sides. It meets at a right angle. If you were to draw a square, and I guess I can do that over here. Let's do that over here real quick. If I draw a square, okay, if I draw a square, all right, then the angle, the diagonals that will have to meet at a right angle. Okay? They'll have to meet at a right angle. And we already know that this angle here, this angle here, this angle here, and this angle here are all 90 degrees. So we know that those angles are already equal. Okay? And then, because it's a square, we know that each of the diagonals have to be the same length. That's why a square is kind of like a perfect shape almost. Okay? Maybe except for a circle, but a square is a pretty good shape at its own. Okay? So, knowing all three of those properties right here, we can say that a square follows suit with those properties. Okay? So in just a moment, we're going to do a couple of example problems using these properties, and we'll be done for today.